question 20 says you have this grid below, and we want to fill the grid with integers in such a way that the sum of the numbers in each row and the sum of the numbers in each column are the same. So 4 numbers are missing, and the number x in the lower left corner is larger than the other 3 missing numbers, and we want to know what is the smallest possible value of x. So this is like a very another very classic kind of question. Like, this is like, maybe you might hear referred to as like a magic square or something, like where the sum of the numbers in each column and the sum of the numbers in each row is the same. So we're given that the sum of the numbers in each row and column is the same. So if we were to take these 3 numbers, -2 plus 9 plus 5, that magic sum is 12, right? So we know that the sum of the numbers, the 3 numbers in each row and each column is 12. You can verify that with this column, right? 5 plus -1 plus 8 is also 12. So to do this question, we know we have this like variable x, right? We don't know what x is. But like, again, we want to like kind of like find out what are these other 3 missing squares in terms of x, perhaps, right? So if this entire sum is 12, that means the sum of this row has to be 12, right? So that tells us that this square in here has to be 4 minus x in order for the sum of the 3 numbers in the last row to equal 12. Now, to continue this problem, notice that like if you want like the numbers here to have a sum of 12, now you can look at like the numbers in the first column. That also has to have a sum of 12. So if you have a -2 and you have an x, in order for the sum of the 3 numbers to be 12, this number in here has to be 14 minus x. Just by like using math and logic, like that has to be 14 minus x in order for the sum of the 3 numbers in the first column to be 12. And if you were to take a look at this, like, let's say this middle column, right? 9, this blank square, and 4 minus x. So 9 plus the blank square plus 4 minus x, we also need that to be 12. So if you were to solve that equation, you would get that the blank square, is equal to x minus 1. So this square here is x minus 1. So now we found like the other 3 squares in terms of x, and we know that the number x in the lower left corner is larger than the 3 other missing squares. So we know that x is larger than 14 minus x, it's larger than x minus 1, and it's larger than 4 minus x. So we're given that. So basically, you can kind of solve each inequality individually, or you can just like kind of inspect it, right? I guess we can solve each inequality individually, right? Like for the x is greater than 14 minus x, we need x to be greater than x minus 1, and we need x to be greater than 4 minus x from the problem condition. So here you get x is greater than 7. Here you get like, I don't know, x is, well, you get 0 is greater than -1, which is always true. And here you get x is greater than 2. So notice if we want to find what is the smallest value of x that works, and just by inspection from these inequalities, we see that x equals 8 is like the smallest one that would like make all of these 3 inequalities true. And that would make the answer choice D. Yeah.